All right. Last week we had talked about various ways to select data, and I believe we had started chatting about being able to group data together, and we had hinted at the fact that there were some limitations, when you started grouping data, just because of the order in which data was grouped, right? The fields that did not participate in the grouping were lost, right? They were not available in the later queries. So let's revisit this idea and see how we could this could be mitigated. So let's reviewing group by. Basically, it allows you to take the values of the fields that you're grouping by, and if the values of those fields are the same, right, they fall into a bucket, right? All the values, all the records, right, by which you are grouping by, where a particular grouping field, if the values are the same, they all fall into a bucket, right? So, for instance, if I'm grouping by a particular column, right? It might be by grouping by my major, right, or grouping by club, or grouping by state, or grouping by whatever field that is shared by a large amounts of entities. Then we all fall in that bucket, right? If I group by state, then all 10 million of us are in that bucket, right? And I don't know how many millions in New York, and so on and so forth, right? We all fall in the buckets of our state, okay? And then you can then start asking, aggregate questions about all of us, right? If we fall in that bucket, then you can either treat us individually, or you can treat us as a bucket, right? As a collection, right? But we have the limitation that when we use group by, you can't have both. You can either treat an individual record all by itself and ask questions about that individual record, or you can ask about all the records that fall in a bucket, right? But if you put everybody in a bucket, then we cannot answer questions about any one individual in that bucket, right? You can either answer questions about the entire set, right, or subset, or you can ask questions about the individual, but not in the same select statement. When you're doing the group by, you can't have quite a mix of both, right? So you might ask, if we all fall in the same state bucket, you might ask such things such as, what's the average salary, right? So we're not asking the salary of any one person. We're asking, out of all the ones that are in that bucket, what is the average salary of those that fall in that bucket? Okay, but we can't, in the same question, also ask, what is the salary of one particular person? That makes sense? We can't mix and match, right? And that's one of the limitations that I'd like to address today, right? And how could we mitigate that problem? So other aggregate questions that we might ask is, who makes most money? Who makes less money? What is the maximum salary? What is the minimum salary? We can't say who. Okay, but we can ask, what is the least salary, or what is the most salary? Right? We can't answer who though. And also in our where clause, we can only operate, right, on columns that participate in the aggregation, because all the other columns, right, all the specific columns, like, if I fall in a bucket and it's by state, well, you can't then ask me questions about my other fields, right? Because you group me by state. Okay, you can't operate on any of those other fields. Okay. So here's an example where we have orders. And we have dates and order price and customer, and by just by visually inspecting these, we see that it looks like if we see Alice looks looks like Alice appears 3 times, Charlie appears twice, and Bob appears 1. Right? So if we group these, we could group maybe by, if we group by customer, we'll see that Alice appears 3 times. They would all fall into the same bucket of Alice. Right? But if we do that, notice that the rest of the information about the particular order price of order number 1, number 3, and number 4, the individual values of those orders are lost. Okay, we could ask, what is the highest, what is the lowest, what is the average, but we can't answer questions about any one individual one. That makes sense? Right, because that information is lost. Same thing for the order date. We could ask, what is the maximum date? What is the minimum date? What is the average date? Well, no, not the average date. But we can't ask about individual dates, right? Because, again, that is lost. So if we group by Alice, we can ask, well, what is the total amount of the orders that Alice made this month? So it comes out to be, 1,000 plus 700 plus 300, so that's 2,000, right? But the fact that order number 4 was 300, that's lost. Yes?
So for using group by, we have to use aggregate.
Yeah, that is intent. That is intent. Yes, that you can ask things about you can ask questions about those that fell into that bucket. Right? You can ask, what is the min, the max, right? That's the only thing you can operate. Right? You can't answer questions about any individual element. Typically, in the select statement, you say what you want calculated, right? What fields you want, right? And so, for instance, if I'm grouping by customer, I can't explicitly tell you what are all the order prices that went in there. Right? I can tell you aggregate things about them, but not any one in particular. I can't ask about those. Right? So I can't say, select customer and then just order price, because there is no order price. It's gone. Right? I can ask max, min, sum. Okay. So I can ask or a sum or max or min and whatnot. Okay, if I group by customer. Just again reviewing what we mentioned last week, if you use just aggregate functions, right, then the group is implied, right? It's implied that we are going to group as if the entire data set were a single group. Okay, meaning all the records fall in the same group, right? And then that means that I can't ask questions about any one individual, okay? And then I can ask aggregates. I can do aggregates, and for instance, sum of, and then any of the fields, and it'll come back with the summation of the max or the min. With the actual value aggregated, right? Because we now have lost, right, the individual order prices, right? We can only answer questions about the aggregate of them, right? If we can also group not just by one column, we can group by multiple columns, right? And what we'll do is that if a record has values for those columns that are the same as another record, for the same exact columns, it has exactly the same value, then those two records fall in the same bucket, right? And we can group that. So, for instance, if there are customers who order the same date, right? So if Alice ordered, something, a couple of things, the same date, right? Then those records for that customer Alice for that same date would fall in one bucket, okay? But if Alice ordered tomorrow some other things, and we group by Alice and the order date, then it would be in a different bucket, right? So we could answer questions such as, over a week or a month, right? If they ordered multiple times per day or per week, right? We can answer questions about those things. Okay. Other aggregates, min, max, sum, average. Now, the if you just ask, sum, order, price, and whatnot. The names of the fields in the select statement, the actual text used to report the results, right? That name is vendor specific, right? These over here, obviously, customer, right? Those fields are the fields you chose for the schema, right? So obviously those, if you choose those fields, then it will be the fields that are for that particular table. But these aggregates, right, the names of those fields, it'll choose, the vendor will choose how to represent it as a valid field name. Okay, probably it'll strip out parentheses, or will substitute them with underscores. Right, it'll remove spaces if you have in there, and we'll come up with a best guess at the name of a field. Right, but again, that's vendor specific. It's not standard across multiple vendors. You can get around that by using the as keyword, right, to give it an actual field name. Right, so for instance, min year or max year, you are explicitly choosing a name here. Otherwise, it would have taken the entire min as grad year, right, with parentheses and all, and that would have been the field name. This is useful if this would be a subquery that then is used by an outer query, right? That would be using the fields that are calculated in the subquery. All right, so let's take a look at the some of the limitations of group by, and what could we do, if anything. One of the problems with a couple of the problems with group by is that to be able to aggregate, right, it needs to be able to classify them into buckets, right? So it needs to first identify what are the fields that match a criteria, right? And once it finds the elements that meet a particular criteria, it then starts aggregating, right? So the limitation is that the records are identified after the where clause, right? After the where clause. So that means that in the where clause, the grouping hasn't occurred yet. And because the grouping hasn't occurred yet, you can't ask things about the whole group because the group don't exist yet, right? So that's one of the limitations. In the where clause, you can't say, return to me all the records where the summation of the records are, right? Or return to me all the students whose average grade is whatever. There is no average because to average, you have to create the groups. But the groups don't exist yet because the where clause hasn't existed yet, right? So the first where is used to identify the groups, right? And then it's aggregated later, right? So you can't use aggregation in the where clause. So that's one of the limitations. The other thing is that the grouping, right, is done before the select, right? So in between the where clause and between the where clause and the select statement is when the grouping occurs, right? The classification occurs, and because it's after the where, we can't use aggregations in the where clause, but because it's done before the select statement, right? We lose all the records, right? We lose all the individual values of the fields, so we can't ask, in the select statement, we can't ask questions or retrieve data that is lost in the grouping, right? Once you put them in a bucket, they lose, right, their identity. They lose the individual values. So those are two limitations that we would like to address here, right? So yeah, so other input fields are removed during the grouping, and non-computed fields are used in the grouping field. So let's take a look at an example. If we go back to the database that we've been using throughout the semester, the university here, consider the question that we posed, I believe what was last week. And we were asking, can we calculate the maximum number of A's? What is the section that gives the most A's, right? And so the question was, this was the approach that we took. We first grouped by section, right? So we took all the sections and we counted how many A's did each section give, right? So here's the section, group by section ID. We found all the section IDs and we counted the number of A's in each section, where grade is equal to A, right? We then use that as a subquery, and we use that to extract which one was out of those A's. We gave it a name, right? A new field called number of A's, and then we calculated what was the maximum number of A's, right? Okay, so this is an illustrated version of this. So here we have 3 sections, 1, 2, 3, and I've highlighted the A's in each section. So section 1 gave 2 A's, section 2 gave 3 A's, and section 3 gave 1 A. Okay, and so if we group by section ID, then all the yellows, right, are in one group. All the greens are in one group, and all the blues are in one group. And I'm sorry if you're colorblind. I think I could add additional cues here of where the groups occur. But nevertheless, notice that if we group by section ID, we lose the fact that student with ID 3 got a B, right? That is lost to us, right? We cannot answer questions about what happened to student 3, right? Because now he's in a bucket, right? And we can't ask individual questions about any one individual student, okay? So we could ask, what's the average student ID? That makes no sense, right? What's the max student ID? That makes no sense either. We can count how many A's, how many B's, right? We could ask those kinds of things. So here's an illustrated version of the query. We group and the count of number of A's. That gives a section 1, 2, 3, numbers 2, 3, and 1. We then use that query in a max number Q's, number of A's, and it gives us 3, right? But because here in the select statement, notice that we don't have a where clause at all, right? We don't have a where clause. So that means that the entire query, right, the entire table here is being used as one single group, right? One single group. If it's used as a single group, then you can only ask aggregates about any one field. Can you ask the maximum section ID? Well, that makes no sense, right? Or average section ID? That makes no sense either. You can ask what's the average number of A's? That you could ask, right? You can ask the average number of A's. You can ask what's the maximum number of A's, the minimum number of A's, right? And that's exactly what we're doing here, right? We're asking the maximum number of A's out of that entire group, right? And it comes back as 3. But notice that because we're in this select statement, it makes no sense to ask about any one individual section ID, right? That is lost, right? You can't ask about any one individual number of A's. You can ask the aggregate of number of A's, but not any individual record. All those are lost, right? So ideally, we'd like to be able to answer these kind of questions, right? You select max, max number of A's, comma. Oh, and by the way, tell me the section. Right? We can't. There is no section. It's gone. Right? They're all in the same bucket. You can't. All that information is lost. Right? Once you've grouped it. So this SQL will not be able to answer this kind of question. Or maybe. So maybe we could have asked it another way. We could have said, okay, well, all right. So return to me the section ID. Right? Where the number of A's is the maximum number of A's. Meaning, we would like to be able to use the aggregate function in the where clause, right? But we can't do that because the groupings don't yet exist, right? The where clause itself is used to generate the groups, right? I have to first run the where clause to identify the elements the records that meet the criteria that then I'm going to group. Since the groups don't exist yet, it makes no sense to use any aggregate functions in the where clause, right? Because the groups don't exist yet, right? So again, it's a problem, right? We can't use individual queries about a particular record, and you can't use aggregates on the where clause, right? So either one of these would fail. So we had suggested, right, that one way to get around this, right, is that we have a query that retrieves all the sections, right? We have this query, the first query that grouped by section ID and just rolled up, the number of A's in each section, right? So it came out to 2, 3, and 1. And we have this other query that said, well, the maximum number of A's is 3. What we could do is that we could now maybe join the two, right? 84 and 83, join them together and ask query number 83. We could ask, oh, I know the number of A's, right? It's 3. I can ask here, which one does it match? And it would tell me, oh, section 2. It matches section 2, yes? Right? But this works only if the number of A's is unique, right? If you have 2 or 3 or 4 sections that have the same number of A's, right, then this wouldn't work. It would tell you, well, these 3 sections have the maximum number of A's, right? Right. It would not be able to tell me unique which one, right? So how can we do it? So this is the query, right? We say where a Q83 number of A's equals the maximum number of A's in query number 84, right? And again, this only works if we have a different number of A's. So anyway, so how can we get around this? So here it is. So having is another keyword in SQL that addresses this issue, right? Of wanting to use aggregate functions in the where clause, right? That you like to be able to use sum or average or max or minimum, right? But use it in the along where the where clause allows us to use operators on the where clause. Okay, so here's a couple of examples where we have an order, a set of orders and we have their order prices and order dates, right? And we'd like to be able to ask, right? So return to me group by customer, notice that if we're aggregating some order price, right? So this is a grouping by customer. So Boone appears 3 times, Nielsen appears twice, and Jensen appears once. And we're asking, group them by customer, and then return the order price. Typically, it would just come back with 3, right? It would come back with 3 buckets, right? But what are we doing here? We're saying, no, I don't want the 3 buckets, right? Filter it so that I only get the bucket, that meets a particular criterion, right? And I can say, well, only return the group that whose order price is less than 2,000. So this allows us to again use this in the where clause, right? Here's another one. Having number of order price above 1,500, so it comes out to be 2, which is I believe Boone and Jensen. Boone adds up to 2,000, and Jensen also adds up. No, Jensen's just 2,000. So it tells you, the ones that are bigger than 1,500 are those 2 buckets, right? Boone and Jensen. Okay. That makes sense, right? All right.